It's UofL Today on 93.9 The Ville. Here's your host, Mark Hebert.
Welcome to UofL Today with Mark Hebert. I am that guy, Mark Hebert, on 93.9 The Ville. So glad you're joining us today. We're talking about all things University of Louisville. We'll be talking about some research coming up that I hope you will find a little bit interesting. In fact, we're going to talk about antibiotic-resistant bacteria in the water you're drinking or the lake that you're swimming in. And perhaps more problematic and potentially harmful, could that bacteria morph into a disease-causing bacteria? We'll have some UofL scientists here to talk about that. And a business that grew out of UofL's entrepreneurship program won some business competitions and is now looking to grow. We'll talk to Nick McRae of MetaCT coming up. But first, is tornado and bad storm season in Kentucky? Is climate change making these weather events worse in our area? And how does Louisville's urban environment, the city environment, impact severe weather? Jason Naylor is an atmospheric science professor in the College of Arts and Sciences, and he's here to talk about it. Welcome, Jason. Good to see you.
Thanks for having me.
You haven't been at Louisville too long, have you?
No, closing in on about a year being here. So.
And you came from?
Purdue University most recently.
Okay. And you teach what? What do you teach? What kind of classes are you teaching at UofL?
I teach some introductory courses for non-majors, just general ed courses. I teach another course on climatology and some courses for the atmospheric science majors on severe weather and about cloud physics and how clouds form and things like that.
Okay. Well, how'd you get into the whole atmospheric science and studying weather and storms and that kind of stuff? How'd you decide that was what your life calling was?
I actually started out as a business major when I went to college.
That's a little bit different.
I didn't like it very much.
Okay.
I always liked science, and I happened to be taking a course on earth science at the time, and we got to a section on meteorology. I thought it was interesting and practical, something that everybody wants to know what the weather is, so it seemed like there might be a good number of jobs in that area. So I got into meteorology, and then when I was an undergraduate student in meteorology, I took a storm chasing field trip in my junior year. That was really fun, and that exposed me to a lot of weather that I didn't get to see growing up in Pennsylvania. So I got really interested in severe weather and understanding storms, and that's kind of what got me hooked on it.
That's where we are. All right. Well, I'm going to ask the question I think every Louisvillian is probably asking, probably everyone in the United States is asking. Are we in for a bad storm summer, bad storm season in Louisville, Kentucky? It's
tough to say. Our long-term forecasting of severe weather hasn't really advanced that much to do seasonal forecasts. I mean, we can talk about the outlook for temperature and for precipitation and things like that. Currently, the outlook for the rest of the summer looks a little bit warmer than normal, but about average precipitation. But trying to break that down into, are we going to get a lot of hail? Are we going to get more tornadoes than normal? We're just not there yet. Severe weather forecasting, to be pretty accurate, we can go a few days at best to really nail down what type of storms and where the storms are going to be. So long-term forecasting just really isn't there yet.
Right. So when we read the Farmer's Almanac and it says on December 22nd we're going to have a 40-foot snowstorm, we shouldn't believe it? Is that what you're trying to tell me?
You probably shouldn't believe that, no.
Okay. We're talking with Jason Naylor from the University of Louisville. He's an atmospheric science professor at UofL. Tornadoes and high winds. Mm-hmm. What is... I know what the difference is, but in terms of science, what is the difference between a tornado and high winds, and what causes the difference?
Well, tornadoes are rotating areas of high winds, and other types of damaging winds that you might see in a thunderstorm are more straight-line winds. So in the case of the straight winds that you just might get a thunderstorm gust or something like that, most of that is caused by just cold air sinking to the ground. So you have a lot of raindrops and hail particles and ice in these clouds. Some of that evaporates and melts. That cools the air down. If enough of that happens, the air gets really cold. So cold air sinks. So it descends to the ground really rapidly and it spreads out. That's typically what you get in these kind of high wind events. In a tornado, you have more complicated things happening. There's some sort of rotation in the storm that gets compressed and amplified. A good analogy is kind of the figure skater effect. So figure skater is spinning around with her arms out, and then she tucks her arms in, and she'll spin faster. That's kind of what's happening in a tornado. There's some rotation that's present, and it gets amplified as that air spirals in towards the center of rotation, and it causes much higher wind speeds.
You always see, for people that aren't scientists like me, and, it's really hot outside, it's a pretty hot day, and then you see this cold front, and you can see the really dark cold front moving in this bank of clouds moving in, you're saying, and they're really low, and around in Kentucky you now say, ooh, that looks like it could be a tornado, a potential for a tornado. So what makes it when when a cold front hits a warm front, does that play any role in forming a tornado?
Yeah, that's one of the necessary ingredients for any type of storm, even a tornadic storm. Not just a cold front, but a front in general. You need some kind of nudge to get the storm to form, and that's what you have along a front. So on one side of the front, you have warm air. On the other side of the front, you have cold air. When those two things run into each other, the warm air has to rise up over the cold air because the cold air is heavier, so that causes the storm to start forming. So that's why you see lines of storms along cold fronts. You see them along warm fronts. There's other types of boundaries. You just need that initial kind of nudge to get the storm going.
We're talking with Jason Naylor, who's an atmospheric science professor at UofL. What about climate change? Is it playing any role in how bad storms are, or how violent the weather has been across the United States?
It's tough to say for certain. I mean, climate change is real, and it's a problem, and there's a lot of misinformation surrounding climate change. And one of those is kind of surrounding severe weather. Anytime that we have a tornado outbreak or even a hurricane, a lot of people like to point to, that being a cause of climate change or a result of climate change. And same thing with like blizzards. Anytime that there's a blizzard, people want to point to that and say that's an evidence that there's no climate change. None of those are true. I mean, there's a big difference between weather and climate change, between weather and climate in general. But as far as how climate change might impact the frequency of tornadoes or anything like that, we don't really know for sure. Certainly storms might be more likely in a warmer planet, but another ingredient for tornadoes is something called wind shear. You want the winds to get stronger with height. And it turns out that in the climate change scenarios that we're seeing in the models, there might be less of that wind shear. So it's not for certain whether or not we'll get more tornadoes or not. We might get areas of more flooding or more heavy rain, but things like tornadoes, we don't really know for sure. Same things with hurricanes. We don't know that hurricanes will necessarily get stronger. Maybe they'll be more frequent. Maybe they'll occur in areas where they don't normally occur. And one of the driving forces of hurricanes is the ocean temperature. So if the oceans get warmer,
which they should.
That's right.
In theory.
So you might start to see hurricanes in areas that don't normally get hurricanes. So just
like Maine or something like that?
Possibly. And just a year or two ago, there were some tropical cyclones. I think it made landfall in the Middle East. That's not normal.
No.
So we're starting to see maybe these things occurring in different areas of the globe. Or maybe we have longer hurricane seasons as well, extending later into the fall or even earlier into the summer.
One project you're working on is to see how the urban environments play a role in weather. Describe that research that you're working on.
Well, the idea that a big urban area can impact the local weather, that's not a new idea. People have been studying that for decades. And there were a lot of big projects in the 1970s. One was called Metro-Mex, where people studied St. Louis in particular and looked at how rain distributions around the city kind of varied. Some areas in the city got more rain than other areas of the city. There were these places that they dubbed rain shadows, where it didn't rain as much as other places around the city. And it turns out that the city itself causes that. There's a number of factors that go into that. One of them is the city's warmer than the surrounding environment. That's the urban heat island effect that I think a lot of people in Louisville know.
We're familiar with the urban heat island effect in Louisville, but so does that mean you get more rain where it's warmer, like in the downtown area, than you would perhaps in Simpsonville, which is 10 miles outside downtown? Not
necessarily. I mean, the urban heat island effect is one of the things. There's also the fact that as the winds blow into the city, they run into buildings, and that slows them down. And there's also aerosols. So aerosols have a big impact on storms and clouds and rain formation. And in an urban center, you have lots of little dirt particles and industrial emissions floating in the air. So all of these things can have an impact. But a lot of studies have shown that as storms approach a big city center, they can split and go around the city, and then they re-strengthen after they go around it. So the question that I'm looking at is that how often does that happen? Is that the norm, or is that just kind of a random occurrence? So I'm looking at how frequently we get severe weather warnings around the Louisville area. Are there specific areas in the city that see warnings more often than other areas in the city? And also looking at severe weather reports. Are they more likely in certain areas of the city and less likely in other areas of the city?
It seems to me, as a longtime resident of Louisville, that the weather seems to follow the river. Is there any does the river play any role at all in perhaps more rain, more bad weather going right up the Ohio River, or not? Or does that not play any role at all?
Probably not. It's not big enough really to have a big influence. Certainly, larger bodies of water can have an influence on the weather, but a river I don't think is going to cause that big of an effect. That's probably likely due to just, I mean, the general winds are, most of the storms come from our southwest, so they kind of maybe flow in a line that's kind of parallel to the river. And once they approach the city, they might split around the city and move more towards southern Indiana and to the south side of Louisville. So that's one of the things I'm looking at is where are those storms most likely to be occurring.
All right. Well, Jason Naylor, everybody's interested in the weather all the time. I'd love to have you back on the show at some point, and we can talk some more about this, all right?
Sure. Sounds good.
Paul Himes and Deborah Yoder-Himes are both biology professors at the University of Louisville. They and their students have been studying bacteria that are antibiotic resistant in water around the Louisville area, as well as whether that bacteria could morph into something more dangerous. Tell us about it. Welcome, first off, to the Himeses.
Thank you for having us.
Glad you're here.
Yes, thank you.
I told you the first question I was going to ask you was, did you two meet in a lab?
Yep. Yes, we did.
You did. Here
At
at
Michigan
UofL?
State.
Oh,
No, at
Michigan
Michigan
State?
State in
Okay.
grad school. I was already in a lab, and he joined a year later. We got him to come in, and he joined. And it was pretty funny because our boss didn't even know we were together until we gave him the wedding announcement.
So here
So we
we
were
are.
pretty good at keeping it professional
Yeah.
at work. So
All right. Well, let's talk a little bit about your work and your research. So Paul, why don't you tell us a little bit about what you're working on?
So what we're interested in is whether or not there are bacteria in the environment around us that could cause an infection that would be hard to treat. So we know that in the hospitals, on every yearly basis, there are about 2 million or so people that are infected with a bacteria that's not able to be killed by at least one drug. And about 25 or so thousand a year people die from those types of infections. And so we know that those infections exist, and we want to know where they're coming from. And so we're thinking about, many of them are picked up in the hospital because people have a weakened immune system, but many of them also are picked up in the environment. And so we want to know where in the environment they're coming from and why are they coming from? Why are they existing in the
So you got
environment?
these bacteria that are resistant to antibiotics, basically, is what you're talking
Yeah,
about, right?
yeah.
And they just exist around us?
yeah, so they're quite prevalent in the environment, and part of the reason for that is because that a lot of the antibiotics that we commonly use in clinics are actually products that are made naturally by environmental bacteria to kill other environmental bacteria. So they're used by these soil organisms to outcompete competitors and to kill competitors so that they can dominate those environments
Or find food.
or find food. And
If I kill you, I can eat you. This kind
yes.
of
And so they're actually very prevalent in soils and waters and kind of the soil underneath waters called sediments, right? And so they're around us all the time, just in the natural environment. And on top of those that are naturally found, we introduce a fair number of microbes that are antibiotic resistant.
So we, in our own bodies, as we take antibiotics, we kill off the bacteria that are sensitive to antibiotics, and the ones that survive are resistant, and we eventually pass those on into the sewer system, and eventually some of those make their way outwards. A lot of livestock grows a lot faster and bigger and stronger if you put antibiotics in their food, and so they get antibiotic-resistant bacteria in their environment as well, and eventually that leaves their bodies and gets into the waterways, and
80% of the antibiotics that are produced are actually given to livestock for growth promotion, and
Right.
they're not metabolized in the animals, so it gets shed into the environment, and that makes microbes in the environment develop or evolve resistance
And
in the
the
environment.
resistance and the immunity to it. So,
Right.
And that's bad.
Right, it's hugely
that's
bad.
because we, as
That's the
humans,
thing.
we're not able to fight this stuff off.
Right. If we have no treatments for these microbes and they're causing infections, we go back to the age where, back before penicillin was introduced, where a hangnail can kill you.
Oh, we don't want to do that.
No, nobody wants that. But the rates of resistance are rising dramatically, and we have to design new ways to treat them, as well as be good stewards of the antibiotics that we do use, and then also kind of figure out where they are in the environment and what's causing those, and then try to figure out ways to remediate that or eliminate some of the environmental sources.
We're talking with Deborah Yoder-Himes and Paul Himes from the University of Louisville. They are both biology professors at UofL, and we're talking about this bacteria and antibiotic-resistant bacteria. And out there in in Louisville, for instance, in the streams in Louisville and in the wastewater in Louisville, you have students actually going and taking samples. What are you looking for? What are you doing with that research?
Well, we're wanting to know what's out there. What is resistant to antibiotics? And so we have students take samples and see, okay, are there things in these samples that can grow if we add antibiotics? And a lot of times there are. And so we're interested in seeing what's growing, what's out there. Are there things that potentially could cause disease? If we find bacteria that are resistant, we've done tests, and some of the bacteria have been able to cause damage to lettuce leaves, and some of them have caused damage to human cells, and others so we want to know, are there things out there potentially that is there a source that could cause us disease in the future? And also we're now looking at who is next to these guys, because bacteria like to share things back and forth. Bacteria are very, very friendly. And
sometimes
when they're not making antibiotics to kill each other.
So the good bacteria may have some properties that may jump to another
Yes,
bacteria.
you can transfer antibiotic resistance from organism to organism quite often.
Okay. Well, what are you finding then? I mean, are you looking at water fountains or Beargrass Creek, or where are you? Where are you taking samples?
Yes.
Okay.
So the latest iteration we let the students kind of take charge and design where they wanted to do their sampling here in the local area. And they chose waters based on researching kind of literature on where microbes are found, and they chose water. So then they broke into 4 teams. One team looked at natural water, such as the Ohio River, Beargrass, and local creeks. One looked at wastewater, so we went out to the wastewater treatment plant out in Floyd's Fork, and we got some from Morris Foreman down here in downtown Louisville. Those are the nastiest.
Yeah.
And then we also had ones that looked at drains surrounding the local hospitals downtown, and agricultural waters too.
So you've looked at waters
the
all over the
livestock.
place, basically.
Yeah. So we had them go out and sample, and then bring them in, and they picked the antibiotics they were interested in, and we identified a number of bacteria in these samples.
So I want to clarify, when we looked at the wastewater treatment plant, we looked at what was going into the wastewater treatment plant, not what was coming out.
Right?
Yeah.
They do a very good job of cleaning
job.
Yeah, they do a wonderful job of cleaning the water.
Right.
No,
we were looking at
what those of us give to them as we put things down our drains.
But the key question here is, what did you find? What were the bacteria? Did you find something you weren't expecting in that? Did you find anything that was dangerous in those samples?
Okay, so I can speak to that because I have a team of bioinformaticists who have been examining this, and it's actually quite a complex question. So one of the main organisms that we're finding from this most recent iteration of microbes that were resistant to 2 antibiotics, tobramycin and colistin.
Vancomycin.
Oh, vancomycin, I'm sorry. Is vancomycin and colistin?
I don't know what either one of them are.
Iterations. And these are commonly used clinical antibiotics.
Okay.
And the number one thing that's pulling out is an organism called Brucella. And Brucella is a genus of bacteria that's interesting. You probably haven't heard of it.
Is that brucellosis? Is that what causes
yes,
brucellosis in cattle?
It is.
See how smart I am?
The actual species we can't identify down to the species that causes the common miscarriages in cattle. But it's within that group. So this genus in general can be opportunistic pathogens for a wide range of vertebrates. And so it's very likely that some of these might cause human infection. However, we have a hard time kind of growing them in the lab and to do further testing on, but that will be
so that's
coming
down the
up
road,
next.
trying to figure out.
Yeah, and we can do that pretty easily with cultured human cells or mouse cells in petri dishes, looking at the effect of those to see if they're a potential source or a threat.
All right. Well, Deborah Yoder-Himes and Paul Himes, great job. I'm really interested in this kind of stuff. I would have given you more time. I should have allotted more time for this interview because this is terrific stuff.
Maybe when we get more results, we can
There
come
you
back.
go. When you get more results, that's exactly what I was going to say. And when you find, okay, here's what's in Louisville's water, here's what's in Louisville's wastewater, and here's what's in our ponds and creeks, and here's the bacteria that are sitting around in there, I'll have you back on and you can tell me what that is.
That sounds
All right.
good.
Thank
All
you
right,
very much.
very good.
Thank
Thanks
you.
for being on the show. MetaCT is a new company that's developed technology for road paving companies to become more efficient. MetaCT was launched by students in UofL's Entrepreneurship MBA program. One of those students is Nick McRae, who's here to talk about his company and what role UofL played in getting you there. Welcome, Nick.
Thanks, Mark.
Good to
Appreciate
see
it.
you. So you took the Entrepreneurship MBA program at UofL.
That's right.
All right. Well, tell me about that.
Yep. So I was in the 22nd cohort there, and we started with a an effort to actually find a concept that we would eventually try to start a company with. So went through an idea journal trying to come up with things that would be a good fit, where there was actually a need, where we had the expertise to go build it. And as my business partner, Max Comer, and I started going through all these ideas, we started to realize that with his experience in the heavy highway construction space, and then my experience having built software and working in GPS technologies, that there was a gap that wasn't being filled in a very specific niche industry in the asphalt contracting industry. So that's kind of where we started the idea from.
So as you walked into the entrepreneurship program and the MBA program at UofL, what were you expecting out of it? Were you thinking, hey, I just need to learn a few skills, or hey, I really want to start my own company and this is the path to do it? What were you thinking?
Yeah, I was coming off of about 5 years of running my own software consulting firm, McRae Technologies. So I had some small business experience, but wasn't seeing just explosive growth and was kind of understanding business the way that I had kind of just figured it out on my own. So I had this expectation that I would get the MBA curriculum and understand, deep dives into case studies and really understand how business administration works. But I also had known some people going through the entrepreneurship MBA program specifically, so I had an expectation that it's incredibly intense, which it did not let me down. And it was, it's the MBA curriculum anybody else would get, but it's kind of mixed with an accelerator almost to go through actually launching a company and coming up with ways to do that. So it was a fantastic experience. It really built confidence and understanding in how to start a company, as well as how to fit it into, grow it to be a larger corporation and that sort of thing.
All right, so you and your partner start Meta CT, and you're the CEO, and you started while you're students at UofL, right?
That's correct.
Okay.
Yeah.
So how does that work? You just say, you know what, let's name this company, and we're going to start this company, and then you went into some competitions. But how did it get started? Then how did you get into the quote competitions?
Yeah, the Entrepreneurship MBA program has a structure where everybody that's involved with it picks an idea, even if it's one that they maybe don't have intentions of really launching, just to kind of go through some of the steps of the program. But at some point, you do a final, it's about midway of the program, you do a final pitch, and there's a panel of judges that are made up of business leaders in the community, past students, and they'll actually give you a nomination to be a competition team. And in order to actually go through and compete, you have to officially establish a company. So we were fortunate to be selected and nominated the first time around, because you do have an opportunity as a second chance team. But then when you actually go start competing on the competition circuit, the money goes directly to that company that's pitching, as opposed to through the university typically. So you have to have an entity formed.
Explain what Meta CT is.
Sure.
What's that company do? What's your company do?
It's a software as a service mobile tracking and dispatch platform. So asphalt contractors typically don't own all of their dump trucks, but they use them obviously for everything, to take the material away from the job site, bring the asphalt back in. So when they're subcontracting these trucks, they don't have visibility as to their location. They're using 2, 3, 4 different trucking companies, and if they have GPS units, they're sending the data back to the trucking company. So our app
Not to the asphalt company.
Of course, the one who would need to know where they're at and of the timeliness. So we have an app that every dump truck driver is going to use, and now the asphalt contractor can see all of those trucks, regardless of who owns them, on one single platform. So it's building fleet management software for companies that don't own fleets. And we also have kind of married in a dispatch and scheduling software along with that. So it really fits a niche need, which is one of the things we learned in the Entrepreneurship MBA program. Is it's not easy to start a company, and if you don't have the passion for it and the expertise in the management team, it's one of the leading reasons why you wouldn't be able to stick with it. So knowing the customers, because we have my business partner, and then being able to build the software and be passionate about it, is really one of those things that's kept us moving forward.
Talking with Nick McRae, who's a graduate of the UofL Entrepreneurship Program, and he's the CEO of Meta Construction Technologies, better known as Meta CT. So then you go into these competitions. Describe what these competitions are, because I don't think most folks understand what we're talking about as far as competitions. When you were a student, you took your company and you presented it to judges in these competitions. So what are they?
Yeah. It's incredibly intimidating, and you would never think it until you're actually up on stage. But it's similar to the show ABC's on ABC called Shark Tank, and you have a panel of judges, and you'll go up and most of our competitions were the similar format, where you have a 10 or 15 minute uninterrupted pitch, and then after that you have an equal amount of time, another 10 or 15 minutes, and any question is fair game about the viability of the business, the financial model, its projections, will it sustain, that sort of thing. And to get up on stage, sometimes it's a small room, there's hardly anybody in the audience. We had been up on the biggest stage with about 100 people watching, and some pretty top-notch judges, and it's intimidating. There's no way to fully prepare for every single question that could come up. which is fantastic for us as we're starting the business because it means we have no choice but to look at every possible outcome and really know our numbers and be confident in the concept. So yeah, it was a great experience for us.
And you did very well. You were in, 4 different competitions?
Yes.
Is that right?
Uh-huh.
And you guys did very well, and you got money for it, right?
Yes, absolutely. It was
So
one of
what kind of cash did you get, and how did that go towards helping you launch your company?
We have an interesting company that, with the management team, where we have an opportunity to bootstrap it. We don't have to raise significant capital to find software developers or get that expertise. So even early on when we were thinking about it is, do we raise money from an investment group, or do we see if we can just let revenues kind of keep the company afloat and do bootstrapping approach? So going through the competition circuit means that if you place, up towards the top, you'll get some non-dilutive cash, which was awesome for us because it really made it easier to take the risk out, fund some of the server, the hosting fees, some of the things that we had, even ramp up our development time to let other developers kind of come in and complement my skills to really get to some of our milestones more quickly. So I think all in, we probably collected around $32,000, and some of those are lines of credit we can draw from. Some of it was just cash in the bank. So
Right.
It's fantastic.
Yeah, so Idea State U Business Plan Competition, the Ballard Morton New Venture Competition, Cardinal Challenge, you finished 3rd. Idea State U Business Plan Competition, you won a little over $15,000 this year from them. So that's a good chunk of change to get you rolling.
Absolutely. And it may be that we get to the point where when that money is depleted or we hit some thresholds, we do decide to raise another round, but we're so close to getting out of our beta testing period and onto production that we may actually start to see revenues kind of even out those cash flows where we don't have to raise any funding. So we're at that point where we're really excited about the opportunities.
Well, that's what I was going to ask you next, is every entrepreneur knows that you got a great idea, you might get some initial seed funding, but there's that gap between the time you get the initial seed funding and the time you actually get your product on the market that you got funding problems. You got to pay the salaries
Sure.
and that kind of stuff. So where are you in that process? How close are you to getting your product actually sold and having companies buy it to use it?
We're looking at the end of July to have the actual beta period close and actually be able to start charging customers. We've been working with Louisville Paving, which is a large contractor here in town, and they've been phenomenal feeding us requirements, making sure what we think we're building is exactly what they need, and testing with us. So we're hoping they'll be one of our first customers, and we have a few others in the pipeline. So then by July, looking at a net 30, to kind of start getting revenues coming in around August. So we'll just be able to finish out the year with showing some positive revenue.
Last question. What would you tell folks who may want to start their own business, haven't figured out a way to do it, and have been thinking about maybe going back and getting an MBA or an entrepreneurship MBA from UofL? What would you tell them about the program?
I couldn't say enough strong positive things about the entrepreneurship MBA program. It's a huge plug for them, but I was a big fan, and it really had a big impact on me. Starting a business in general is not to, I guess, redundant because I said it a few minutes ago, but it's really tough, and the idea that you have, if you're not 100% positive that it's got a good market, good customer base that's willing to pay for it, or you're not totally passionate about it, where when you hit those valleys that you're not going to be able to keep going through, it may be something to reconsider, or at least make sure you know why you're jumping into it. It seems like you could get into it maybe and regret it later. So it's a lot of work, but it's also a lot of fun, incredibly rewarding. So
good deal.
Yep.
All right, Nick McRae, glad you came to UofL. Glad you got your business off the ground.
Thank you very much. Appreciate your time.
Good luck. Good luck in the future. Thanks for listening to UofL Today with Mark Hebert, and go Cards.